Today's lesson is adding and subtracting polynomials. Now, you might ask, what is a polynomial? Well, a polynomial is an expression with terms that have no variable in the denominator and no fractional exponents. It's basically what we've already been working with. So here are two examples of polynomials. 6x squared plus 2xy plus 5, 3ab squared minus 2b plus 5a minus 1, and there are infinite number of polynomials. We've been working with them basically since you started algebra. Now there are specific types of polynomials called a monomial. A monomial is a polynomial with one term. You probably figured that out from your understanding of the prefix, mono. Now here are two examples, 4x squared and m to the 6th. Those are all monomials. One term. It can have multiple pieces to it, but it's only going to have one term. There will be no addition or subtraction sign to separate them. A binomial is a polynomial with two terms. So some examples that we have are 9x plus 7, 8y squared minus 5yz, and you could think of a million others. And then a trinomial is a polynomial with three terms. And again, you can see the examples below. After trinomial, we really just call anything bigger than three terms, we just call it a polynomial. Now, when we write polynomials, we write them in a certain order. In order to do that, we need to know the degree of the polynomial. The degree is the largest sum of the exponents of the variables of a term of a polynomial. I know that's a lot of wording, so let's look at this in terms of numbers. The first term is 7x to the third, y to the 5th. So the degree of the first term is 5. 3 plus 2 is 5. We look at just the exponents. In the second term, we have x to the first and y to the third. So the degree is going to be 4. The invisible ninja 1 plus 3. In the third one, it's 9. 6 plus 3. The fourth one does not have a variable, so it's a degree of 0. And the last one only has one variable, and so it's just the degree of that variable, the exponent of that variable, which is 5. So the degree of each term is determined by the number of exponents, or the sum of the exponents of the variables. The degree of the polynomial is the biggest degree of one of the individual terms. So the degree of this polynomial is the degree of 9, because we have a term right here in the middle that has a degree of 9. So the biggest degree of one of the terms becomes the degree of the polynomial. When we write polynomials then, we want to write them in descending order, meaning ordering a polynomial so that the sum of the exponents of each term decreases from greatest to least. A couple of other definitions that go with that before we look at it is the leading term, which is the first term in descending order, which has the highest degree. And then the leading coefficient is the coefficient of the leading term. So it's the first term after we've written them in order from least to greatest, based on their degree. So if we look at the example above, we're going to write the degree of 9 first. 2x to the 6th, y to the 3rd. Then we're going to have a degree of 5, and we actually have two of them to the 5th degree. So it doesn't matter which order we put them in. In this example, I put the 7x to the 3rd, y to the 2nd first, but we could have switched it with the negative 11x to the 5th. And notice I have to take the entire coefficient, so the number and the symbol in front. That's where the negative 11 comes from. Then we write the degree of 4, negative 6x, y to the 3rd, and then something to the degree of 0. So we want to write things in descending order from the biggest to the smallest. Our leading term, then, is the first one, the one to the 9th degree, the one that gives our polynomial its degree, 2x to the 6th, y to the 3rd. The leading coefficient is 2, the number in front of the variables. Okay, so there's a lot of information, and go back and review it if you need to. But find the degree of each polynomial and write the polynomial in descending order. Try these examples, pause the video, and when you're done, you can restart and check your work. Alright, so in the first one, you're going to write 2a to the 9th, b to the 2nd first because that has a degree of 11. The next one has a degree of 9, then a degree of 8, degree of 3, 2, and a degree of 0, so it's in descending order, and the degree of the polynomial is 11. In the second example, 10k to the fifth is going to stay first, but then we're going to move 16k to the third, minus 20k, plus 14, and the degree of this polynomial is 5. Now, with all of that understanding, we're going to actually talk about operations with polynomials. Now, the good news when we add polynomials is it's just combining like terms of two or more polynomials. You know how to do this. It's really nothing new. So if we look at our first example, 4x to the third minus 7y squared plus 12x minus 12 plus 3xy, all added to 8y squared plus 20 minus 7xy plus 6x to the third, what we're going to want to do is just combine like terms. So 4x to the third and 6x to the third combine to 10x to the third. Negative 7y squared and positive 8y squared gives me 1y squared. 12x unfortunately does not have anything to combine with, so it just goes by itself. Negative 12 and positive 20, that gives me a positive 8. And 3xy goes with negative 7xy, which is negative 4xy. Now remember, we always want to write these in descending order. So we're going to rearrange these so that my order is least or greatest to least. So 10x squared is a degree of 3. Both of these have a degree of 2. So you could have these in either order, degree of 1 and then degree of 0. In the second example, 12a to the fourth has no like terms. Then we have 9a to the third plus 8a to the third is 17a to the third. Negative 21a and positive 4a is negative 17a. And 3 and negative 17 is negative 14. And then the negative 16a squared also has nothing it combines with, so it's added on. Writing it into descending order, we have 12a to the fourth plus 7a to the third minus 16a squared minus 17a minus 14. So this one has a degree of 4. Subtracting polynomials is exactly the same as adding, but we must subtract the terms instead of adding them. We can make this easier by changing the subtraction sign to addition and multiplying each term by 1. So let's look at this first example. We have the polynomial 4x to the third minus 7y squared plus 12x minus 12 plus 3xy minus 8y to the second plus 20 minus 7xy plus 6x to the third. So what we can do for subtraction to make it just like adding is we can change the second one. We change the subtraction sign to addition, and then we have to distribute the subtraction sign in front of each one. So this becomes negative 8y squared, negative 20, while negative times a negative is a positive 7xy, and negative times positive 6x is negative 6x to the third. So really we just flip the signs on all of them, but now it's an addition problem where we combine like terms, negative 2x to the third. We have negative 15y squared. 12x has nothing to combine with. Negative 12 and negative 20 is negative 32. And positive 3xy plus 7xy is 10xy. Write it in descending order and we get negative 2x to the third minus 15y squared plus 10xy plus 12x minus 32. In the second example, we're going to do the same thing. We're going to change the subtraction to addition and distribute or multiply everything by negative 1. So we get negative 8a to the third. Negative times a negative gives us positive 16a squared. Then we get negative 4a, and then again positive 17. Combining like terms, 12a to the fourth combines with nothing. Positive 9 and negative 8 gives me a positive 1a to the third. Negative 21 and negative 4 gives me a negative 25a. Positive 3 and positive 7 gives me a positive 20. And when we put it in descending order, plus the 16a squared, I almost forgot. When we put it in descending order, we get 12a to the fourth plus a to the third plus 16a squared minus 25a plus 20. Try these examples. Pause the video and see if you can add and subtract these examples. The first one, you should get negative 10h to the 6th plus 6h to the 5th minus 3h to the 4th. And example 2 should be negative 4cb squared plus 5b minus 17. If you didn't get these answers, please check your work and then bring questions to class. And I know that was a long video, but thank you for making it to the end. We're going to practice more in class. If you have any questions, bring them to class.